Hey guys, welcome back to the course. This lecture is all about the code which is required to solve the use case we introduced in the last video. For this use case, we will again be making use of the netmiko library and the datetime class. One new library that we will be using here is called OS. This is used to determine the operating system of the machine where this code is being run. I will explain its use later on in the code. Before we start dissecting the code, let's run it first so that we have some visual idea to correlate the lines of the code with the actual output. I'm entering a bunch of information here on the console. You can ignore it for now. We will go through it while understanding the code line by line. Here, we start off by initializing some variables with different values. We are basically working with four files. The IP file will store the IP addresses which are found to be active on the network. The log file is supposed to capture the log details of those devices which are not active on the network. The error file is supposed to capture any exceptions during the execution of the code. And finally, the device file is going to capture the iOS version and uptime of the network device which is found to be active on the network. The first function we have is called accept values. Here we are making use of the try and except block for exception handling. If you have not watched the lecture on exception handling yet, then please do that first so that you are in a better position to understand what we are doing here. All this code is going to reside under the try block. Here we are asking for a sample IP address from the user. As you can see on the console, this is where I provided the 10.1.4.15 address. In the second variable, the CIDR value of 24 is hard-coded and these values are stored in their respective variables. Since this is for demonstration purposes only, we have kept the CIDR value hard-coded to 24, but if you want, then you can easily prompt the user for that and then use it later on. We then use the split function and use the dot character as the separator. The idea is to separate the 4 octets of an IP address into 4 individual values. The split function basically creates a list of elements, which means that each octet is going to become an element in the list. So if we correlate it with the IP address that I provided, it means that the list is going to contain 4 elements, 10, 1, 4, and 15. After that, we have this variable net_add2. Here we are basically keeping the first 3 elements of the list we created above. As you can see, we have given only 3 index values, 0, 1, and 2. The last index value is missing from this. Then we print this message, which basically provides the host range of the subnet under which our initial IP address falls based on the CIDR value of 24. After that, we ask the user to provide 2 values, the initial host number and the last one. As per this message on the console, we can have 254 hosts ranging from 1 to 254. So if we want to scan hosts 20 to 30, then we need to enter number 20 as the first host and 30 as the last one. This is followed by a simple ping command with a count of 1. Then we run a simple for loop which is going to run in the range between the first host and the last host. Within this for loop, we are executing the ping command using the OS module's popen method and capturing its output in the variable txt. The idea is to run a simple ping on every IP in the range between the first IP and the last IP. In the next statement, we check if this output has the word TTL in it. If it does, then we open this file called IP_file and write the IP address in it. However, if the output does not contain the word TTL, then it's going to mark an entry in the log file with this message that the IP address is not pingable. This is how we are tracking those devices which are not active on the network. Finally, we have the accept block. Here we are doing 2 things. We are first printing a user-friendly message to the console which says that an unexpected error has occurred. The application team is analyzing the logs. Please try after some time. Simultaneously, we are also writing a more technical message in the error file so that our technical teams can do the detailed analysis later on. Now let's run the code again. Here I'm entering the initial IP address. Then I get the message indicating the host range. Now I only have one router in my lab and its IP address is 10.0.0.15. In order to demonstrate the complete functionality here, I'm going to mention 14 as the first host and 16 as the last. Since there is no router with IP 10.0.0.14, the ping is going to fail, and that information will be logged into the log file. And 10.0.0.15 is active on the network, so that IP will be written in the host IP file. Let's hit enter and see what happens. It's going to take a few seconds to complete the subnet scan. As you can see, the code was executed successfully. And if we check the files, we see that the host IP file has the IP address of the active network device and the log file has the IP address of the failed network device. Now let's look at the second function, which is using the information from the first function as a base to capture some additional router information, like the iOS software version and the device's uptime. Here we are opening the file that contains the IP addresses of the active network devices. This is the same host IP file that we prepared in the first function. Then we use the readline function to read the contents of the file in the form of a list. Then we run a simple for loop and send this show version command to the router using netmiko library. The output of the showrun command is then split using the split function, and this time we are using the return or enter key, which is represented by /n, which is the regex pattern, as the separator. This will create a list and it will be stored in a variable called s. Then we open a new file called device details and we write the IP address followed by these two list elements 0 and 20. These two list elements contain the iOS software version and uptime information. If we run the complete code now, we should be able to not only get the IP details of the active as well as inactive devices on the network subnet, but also get the iOS software and uptime details of the active network devices. Let's run it now and see what happens. As you can see, we have the active network device's IP in this file, then we have the IP of the inactive device in this file, and finally, we have the iOS version and uptime details of the active network device in this file. This completes our beginner-focused journey into the world of network automation. I hope you were able to derive some value out of it, and you now feel confident and excited to continue your learnings even further. So with that, I thank you for joining me in this journey, and I hope to receive your feedback and reviews in the comments.